Okay guys, this is the video that's very important in terms of using the calculator. Now on this first sheet for day 5, there's a step-by-step guide on how to input data, how to plot it, then how to get the equation of the line that best fits it, and then how to graph that. Now, the thing that's most important to me right now is being able to put the data in, being able to come up with your equation. So we are going to spend time doing that. The first thing I want to bring your attention to is you want your diagnostics on for this part. In order to do that, all you have to do, and most of you guys probably have it on anyway, you go down to second, you hit second, and then go to catalog down here by the 0 and hit that. And now you're in the catalog. This gives you every single command the calculator has. Notice how it has an alpha up there. We want to go to diagnostics, so I'm going to hit the D, which is the X inverse button. And now I'm in my D's. And I'm just going to go down to diagnostic on. Okay, and again, this will turn our correlation on. You should see that, and then you just hit enter again, and it says it's done. Okay, so the next thing we want to do is how to enter in data. I want to enter this data in, and again, this sheet has a step-by-step, but I'm going to go through it and kind of condense it so it's not as, there's a lot here. You go to stat. Stat is right above the program button. You hit edit. Now, before, let's hit edit and see what we have. Okay, I have data in here already. So what I'm going to go up to is I'm going to highlight list 1. Do not hit the delete key. You do not want to delete the list. You just want to clear the list and hit enter, and then it should clear the whole list for you. Go up to L2, clear, enter. That's if you have stuff in your lists. If you don't, then you can just start here. So you want to enter the X values first for your L1. So my X values are 5, 7.4, 9, 12.2, 15.1, and 3. Okay. Now we enter the Y values that correspond to those X values. 4, 3.3, 2.5, and I just typed in 2.1. There we go. 2.5, 1.7. Now here's the thing. You have to be careful when you're doing this. If you enter something wrong, you're going to get something wrong on your quiz. So double check before you hit anything. Those all look good. Those look good. Okay. Now, again, the other thing you want to do is check your y equals, and I'm going to clear that too. Okay. And now to get back to your home screen, just hit second mode. That gets you back there. Now, I have my data in there. Again, the sheet goes through how to plot it and look at it. Right now, I just want to come up with an equation that will model that situation. So you go back to stat once your data is all in. Move over to the calculate section, or calc, and you will see all these different things. Well, we are working with linear equations, right? Linreg, ax plus b. So what this is going to do is it's going to give me the line of best fit that follows this model in terms of, and it'll give me as the equation y equals mx plus b. In this case, they say ax plus b. Now here's the nice thing the calculator does. Before you hit enter a second time, because to hit enter the second time you'll get your answer, we want to store this in y1 so we can then look at the graph and use it as a function later. So just like we've been doing with function notation, go to vars, yvars, function, y1, and then hit enter once you have this information. Alright, so what you get is you get negative 3.8177 for A. B is the y-intercept. Notice these R values. These are your correlation. The closer they are to 1 or negative 1 means the closer how good the line of best fit is. So these are pretty good since they're at 0.97 and 98. I believe we want to look at just R there. So anyway, now what you should look at though is go to y equals. And there is your equation already thrown in there for you. So now if I asked you, what is y when x is 7, you can now do what you need to do here. you can just go to window function and go, okay, well now I have that new function I made. I want to know what it is at 7, and you'll get a value. Okay, so that's the most important thing to know how to do. There's a lot more in terms of graphing it, but if you can do that, you're good for the quiz. Alright, so let's try another one with this. I'm going to pause it and go down to the next screen. I forgot to mention one more thing actually on this screen. If for some reason you go to stat and you want to clear these and you accidentally, let's say you accidentally do this. Instead of hitting clear, you hit delete. Now look what happens. I don't have L1 anymore. I'm starting at L2. The calculator doesn't work like that. You have to have L1 in there. So if you lost L1, here's what you need to do. Just go to stat and go down to 5. Setup editor will bring everything back to normal. So enter, enter, done. If you go back to stat edit, the L1 should be back there. And it brought actually the values back. So now this time I'm going to clear and hit enter. And I did. Okay, so anyway, setup editor. Here it is right here. Setup editor if you delete a list by accident. Important thing to know. Okay, now I'm going to go to the next page. Alright, now we're going to look at this next one. It's basically the same thing. Here's the only thing I want to talk about. The data starts at 1986. To make the data nicer, let's set t equal to 0 at 1986. So we're like starting at 1986. So that means this corresponds to 1, 2, 3, 4, 5, and double check that the numbers are all going in order. If it jumps from 91 to 93, 93 is not 6, it's 7. But it doesn't. Okay, whenever we're dealing with years, I'll usually tell you, and this one didn't tell you, but usually when we're dealing with years, you want to start at year 0 for that year that they give you the data for. Okay, write a linear equation for the data above. Alright, well let's plug in this information. Okay, bring your calculator up. Let's go to stat, let's go to edit, and let's start typing in our data. Again, it's good that you practice this. There is a problem on the quiz, on the test, on the final. You pretty much need to do all this. So it's good to know how to do the calculator. If you are completely lost on the calculator, there will be time in class that I will go over individually if there's just someone that's very confused to help them out. But the good news is you will have this video to keep going back to if you need to look over something. Okay, so maybe flag this video, or I don't know how you can do that, but make a mental note that this is the video that goes over how to enter data into your calculator and then gives you answers. So I'm just entering it. Sorry that this is, I just realized maybe I should have had this in there already for you. All you're doing is entering data that corresponds. Make sure it's correct. 13200 and finally 13800. Okay. So I have my data in. I'm going to hit second quit. I'm going to clear Y1 just so I don't have that anymore, and second mode again. And now I'm going to come up with my equation again. Now the nice thing is, since I've done this already, I could probably go back and find the function, but there it is, linreg of ax plus b. If you keep hitting second enter, it'll bring back your last couple entries. So now I can just hit enter. And there is my new equation. Okay, round to 3 decimal places if you were writing the equation and rounding. So let's do that. We have the A value is 830. We have the other one is 7124.4, I believe. Yep, 7124.444. Alright, so linear equation. Now, I did not give you any variables to use here, but since I'm talking about cost in a year with t, why don't we use those variables? C of t, I'm using function notation, the cost with respect to years is equal to the slope of 830 t plus 7124.444. Okay, this would be the linear equation. You can write, if you wrote just C, if I didn't ask for function notation, you could have done what you wanted. I'm just trying to get you guys accustomed to that. Alright, now it says use the equation to predict the tuition in the years 2003, 2004, and so on. First of all, we have to figure out what years these are. Well, if 86 is 0, 96 would be 10, 2006 would be 20. So this represents t equals 20. We don't want to actually put in the values from that. So what we can do now is we can either use our function here, or we can look at the table that we just created and go and look at the table and see what we have from that. So if I go to second graph I should say, there should be a table now based on this. Well, first of all, we have to go down to the things we want to look at. So I want to start at 17, 18, 19, 20. Alright, so here we are. Now, to get a more exact answer, and since we're dealing with tuition here, we can round these to maybe cents, so 2 decimals for money. So 17, if I move over, it'll tell me it's 21234.44. So 21234.44 for 2003. And if you keep looking at that table and go up, you should see 22,064. Assuming 0.44, these will all be 0.44. Okay. So, and so on and so forth. 05 was 22,894, and 06 was 23,724.44. Again, that's how you have to enter the stuff into the calculator. Your calculator is a great tool to help you model equations. So now what we're going to do is just talk about correlation with this, and this should kind of go pretty quickly. It goes with it. So let's look at the 2.5 note sheet, which is the next note sheet, and we'll go from there. Here it is. Oh, I'm still okay. I didn't know if I was still recording there. All right, so here we are. We're on types of correlation now. Correlation just means how is the data relating to itself. So if I gave you a bunch of dots that look like this is my data. Now obviously it's not perfect, but generally you see a positive line. A line you could probably draw through that. Positive correlation is basically when your y goes up as x goes up. Okay, some things with that would be the more calories you consume, the more weight you gain, something like that. That'd be positive correlation. The hotter it is outside, the higher the temperature gets, the higher Mr. Vranick's electric bill is, because he's running the air conditioning more. Those are positive correlations. As one goes up, so does the other. Negative is the opposite way. You might get data that's kind of all over the place here, but generally has a negative correlation. Again, it's very similar to positive except for opposite. Y goes down as x goes up. You can think of this as the number of gallons in your gas tank versus the number of miles driven. Obviously, if you fill up your gas tank and haven't driven anything, you have a lot of gas in your car. The more miles you go, the less gas you will have in your car. That would be an example of negative correlation. No correlation is if you have a bunch of random data that doesn't even look like you can make a line through. No correlation means that you cannot determine a trend. Okay, no trend there. Alright, so fitting a line to data, pretty much all you have to do here, you want to try, this is just saying how, if I gave you data, how could you fit a line? You basically want to get the same amount of points on either side. This one's kind of an outlier. but let's see, and pick 2 points maybe to go through. Something like that. That's kind of a line that would fit the data. That's all you had to do for that. So generally, though, you're going to have to come up with the data. All right, so here we go for another entering into the calculator. Data below represents the number of U.S. births from 2000 to 2007, where X is in years, and since 2000, so that means that this is representing, again, 2000, but we're going to use 0, and Y is in thousands. So this is basically 4,158,000 people. All right, so draw a scatter plot of the data. Let's draw a scatter plot. I'm going to just say 0, 1, 2, and so on and so forth. I need a 7. And then we have to do thousands of births. So it looks like the data goes from 41 to like 38. So I'm going to do something where there's a break in the data. And this is, again, this is going to be years after 1990. Well, actually, we're doing 2000, aren't we? Years after 2000. And this is going to be births in thousands. You guys have to be very careful with labeling, because if it doesn't work out, then it just makes everything wrong. If you use the wrong label, or you just say the number without thousands after, then you're just telling me there was 3,000 births, not 3 million. Alright, so let's do this. We have 3800, 3900, okay, so now I'm going to plot my point. 0, 4158. 4158 is about there. 1, 4111 is about here. 2, 4065, that doesn't move much. 3 and 4000, that also doesn't move much. 4 and 3953. Oh, I just made that. Hold on. Reverse, reverse. 4065 would actually be here, and 4000 is right here. That makes more sense. 3953 would be about here. 5 would be 39, so that's about here. 389, that doesn't move much. And finally we have 3895, so that's right there. So there is a trend. Unfortunately, it's not perfect. So just to come up with a line of best fit, you can kind of, draw one like that. Then it says use the line of best fit to estimate the number of births in the year 2000. Well, again, this is where you would use your calculator, enter the data into your calculator. I'm not going to show you that again because you're going to probably be bored to tears. So what I'm going to do is I am going to just give you guys what the information should be when you are done with that. Alright, so you should get the number of births, and it said use y and x. So y is equal to negative 41.464 when I round to 3, x plus 41.750. Now, it is good to have that 0, even though because I say 3 decimals. If it only goes 2, give me that third one. So that is the information. Now I'm going to actually use the calculator y1 and see what my value is. And when you do the vars, y1, and you put in for that, they want to know 2010, which would be 10 for x. You get approximately, y is approximately, I should say y of 10, we're inputting a 10, 37,27,000 births. Now, it is 3727.1. However, we don't have enough people to go up to the next value, so just round down to 3727,000 births. Okay, and that is how you would use your calculator to get that information. Just plug it in. Again, I'm not going to show you it again because we're running a little long here. Now, interpolation and extrapolation, really easy. Interpolation, think inside. Extrapolation, think exit or outside. Interpolation is when you're estimating within the range, the given range, given data range, let's say. Whereas extrapolation is estimating outside the given data range. What that means is that if I ask for, and actually I can give you an example with the one we just did. If we look at the last problem, I gave you a data range of 2000 to 2007. Sorry, pause the video here if you need to keep writing that. Then I said use the line of best fit to estimate the number of births in the year 2010. Well, is 2010 within 2000 to 2007? No. This would be outside the data range, so this would be extrapolation. We're estimating outside the given points. If I would say estimate it halfway between 2002 and 2003, so 2002.5, then that would be interpolation. I'm asking for a number inside the given data range. Okay, so that is what that is, and again, we will cover this tomorrow more in class, and I'm going to actually have you guys do one or two more of these in class with your groups, just so I know that you guys know how to use your calculators properly. Okay, that went a little long, but not as bad as I thought with all the calculator stuff, so I will see you guys the next time we have class.